Good morning, everyone. Today we are going to discussing about the compute network. So in that one compute network, we are going to discussing about this transmission media. So what is meant by this transmission media and how it going to works and what kind of transmission medias are available while we transmit information from one end to another end. As we discussed in previous slides, we discussing about this OSA model as well as we discussing about this TCP/IP reference model. So there in the both the models, in the both the reference model, the main medium is a physical layer, which means the transmission layer. So the information is transmission from one layer to another layer or one protocol to another protocol. We are playing a key role of this transmission media. So today we are going discussing about depth of this transmission media. So what is meant by this transmission media and how it shows impact on my physical layer. So any kind of transmission media. So the transmission media, which means a communication channel that carries information from the one sender to the receiver. So we having as n number of transmitters there as well as n number of receivers are there. So here information is transmitted from one end to another end. So one channel to another channel. So we are using the transmission medium that we are using communication channels. So here we have n number of transmission mediums are there, n number of communication channels are there. So here information is transmitted either binary information, which is 0s or 1, or else we are going to discussing about this continuous information. So there we having as different kinds of channels we are using accordingly based upon the information transmitted either in the digital formation or in the analog formation. We are going to using different kinds of channels. The main functionality of this transmission media is to carry information from in the form of binary numbers, in the form of bits, because in the any kind of transmission media, in the nowadays all the world goes to be digital communication world in the digital level. So the information is transmitted in the form of this binary formation, in the form of these bits. That should be in the form of this a local area network. As we discussed earlier, we having this n number of communication networks are there. We have LAN connection, MAN connection, WAN connection. Similarly, the information is transmitted through the bits that to the in the form of this local area network. And this is the information is transmitted, the physical path between the transmitter and receiver, that should be comes to this data communication, because while we transmit information from one end to another end, so here information is we have to give a prescribed path. That path we calling as a physical path, the physical path between the transmit receiver in the form of this data communication, in the form of this binary numbers, which is 0 and 1. And this transmission medium having as two different types are there based upon the information we are transmitting, based upon the communication path we are choosing. We have two mediums are there. One is wide media, another one is wireless media. So what is meant by this wide media and what is meant by this wireless media? So wide media in the sense, if we are using any kind of physical communication path, physical communication links or any kind of cables, we are using information transmission between the source and receiver, that we calling as a wide communication, which means a physical communication path is established between the source and receiver, that we calling as a wide media. And what is wireless media? In this wireless media, we don't have this any prescribed path between the source and transmitter. The information is transmitted through the wireless communication using some kind of antennas, using from AM antennas to till we are using this terahertz antennas, that in the form of this wireless communication only, that we calling as a wireless media, which means we don't have this any prescribed physical communication cable or presence in this medium. We are using either any kind of some antennas, that in the form of this wireless domain values only. And this can be characterized based upon the what kind of signals we are using, that one, what kind of modes of propagation we are using, that one. Based upon this one, we can able to choosing either wide media communication or a wireless media communication. And how we are able to choose these different properties? We can able to choose the different properties based upon what kind of bandwidth we are using, that one, and how much amount of delay is there, and what about this cost perspective, and what about this installation prospect. All these things we take into the consideration, and we are choosing the different kinds of transmission media. So while you see in the classification of transmission media, we have main two things are there. One is guided media, another one is unguided media. Apparently we saying as this we calling as a wide media, and this we calling as a wireless media. So what is wide media? So the physical communication path is established, that we calling as a wide media. There is no physical communication path is established, but through some kind of frequency level, or else we are in some kind of antenna structure level, that we calling as a unguided media. So while coming to this guided media, So in the guided media also, we have n number of cables are present over there. Based upon our requirement, we can able to choose the properties. We can able to choose the respective cable structures. Like we having as a we having as n number of cables are there. When we go for this guided media, we having as n number of cables are there. We go for this a twisted pair cables. We have that one. We have twisted pair cables, and we having as a coaxial cables. We having as a fiber optic cables, and so yeah, we have n number of cable structure. We are using that one. So based upon the requirement, which means based upon the frequency we transmitted that one from one end to another end, and how much distance we transmit that one, which means what kind of bandwidth structure we are using that one. Based upon that one, we are using the different cables are there. Why in the sense, when you go for this a normal connecting wires, a twisted pair cables, they may allow the frequency of this 50 Hz frequency levels at 5 volts power supply level. So this is used for specific application of AM communication and FM communication. But when we go for this a high-end communication, we go for this a TV communication or a broadband communication, we can't able to using this a connecting wire communication or twisted pair communication. There we need to establishing the high range communication, high range kind of structure we are using that one. So when you go for this TV and broadband connection, there we are is this very high frequency value or else ultra high frequency value. So there the twisted pair cables or connecting wires is not suitable for my requirement because of the frequency structure is different. Because here I'm using the frequency of 50 Hz, but here I'm using the frequency in the form of this megahertz level. At the same time, we are using the power supply up to 230 volts, but here is the power supply is 5 volts. So due to that kind of delay formation, due to that kind of structure formation, we are going to using a different kinds of structure, just coaxial cable structure. And similarly, when you go for this Wi-Fi communication, the best example is Wi-Fi communication. Wi-Fi communication is the light rays in the formation form only from one end to another end. So their coaxial cables are not suitable for me. To overcome those kind of scenarios, we are using this a fiber optic cable. So here, based upon the requirement perspective and how much amount of frequency and how much amount of power supply is transmitted, accordingly we are going to choose the respective cables. We'll go for this coaxial cables or fiber optic cables or a twisted pair cables. So in this one, again n number of types are there. We'll go for this coaxial cable, we having as a baseband or as a broadband communication. Unless we'll go for the twisted pair cables, we having as unshielded pair as well as shielded pair. Because when the information is transmitted from one end to another end, it has to producing a radiation emission value. So this radiation emission value, it may affect the susceptibility values and interference of the information. So the information is damaged. To overcome that one, we are going to using a shielded cable. And all the times we are not using this shielded pair cables due to some short range communication is unshielded also required for me. So I'm using this unshielded twisted pair cables as well as shielded twisted pair cables. And while coming to this unguided media, so in the unguided media, the name itself is there, is we don't have any kind of physical cable is presence is required here. So based upon the frequency supply, so what is radio waves, what is microwaves, and what is infrared waves. So all these are depending upon the respective frequency domain only, respective frequency structure values only. For example, if you go for this radio waves, we having the frequency in the form of this kilohertz to megahertz level. When you go for this microwaves, the frequency structure should be in the form of this gigahertz or else in the form of this terahertz. So based upon the frequency structure, we are going to choose the respective antennas, respective frequency path structure only, that we are going to interface to my unguided media structure values only. And so while coming to this guided media, so what is guided media? As we discussed, the physical medium through which signal are transmitted is kind of physical medium. The physical communication cable is present in this media, that we calling as a guided media. So what is twisted pair cable? In the guided media, first thing is we having as a twisted pair cables. In the twisted pair cables, we having as a two things are there. One is shielded, another one is unshielded twisted pair cables. So in the twisted pair cables, which means we have taken two different wires are there. Two different wires we are going to twist it over here to suss up the emissions values only. So twisted pair consists of two insulated copper wires arranged in a regular spiral pattern values only, which means when we taken about this insulation of these cable wires, right? So for example, this is a one type of wire, this is another type of wire. We are going to twist both the wires, so that information is arranged in the form of this spiral pattern values only. So while I'm using this twisted pair cables, which means it shows impact on the reduction of noise interference and the number of turns per foot levels. So how many amount of twist is required for that one. So based upon the twist, we reduce emission values. It shows impact on is reduce the noise interference values only. And if these values, it shows increase the number of turns per foot, which means decrease the noise interference. At the same time, so the frequency range of twisted pair cable is from 0 to 3.5 kilohertz level. That is the reason this kind of frequency level generally we are using is AM communication, and some parties should be AFM communication as well. So here when we twist the pair cables value, how many n number of twists should be possible? So how many twists is possible between the two kind of cable, two insulated cable, that shows impact on reducing the interference. How it shows reduce interference, which means the emission is reduces. If emission is reduces, it shows impact on the output performance level. How it is impact output performance level? To decrease the noise ratio, and 100% of signal is transmitted from source to destination, transmitter to receiver value. That is the advantage of this twisted pair cable. But the twisted pair cables, we are having as limitations are there. What is the limitations? The power supply should be very limited value, which is 3.3 volts to 5 volts power supply value, and frequency structure also, that should be in the form of this 0 to 3.5 kilohertz levels only. And so in the twisted pair cable, we have two types are there. One is unshielded twisted pair cables, and second one is shielded twisted pair cables. When you see this one, in this unshielded twisted pair cables, we don't have this any kind of shield here, and in the shield twisted pair cables, we having as a shield is there. So based upon the shield values, right? Based upon the shield values, because in this one we are using the insulated material. If any cable is mismatched, any cable is short circuit, any cable is damaged, it shows impact on the performance of noise reduction. So that is the reason we having as two types of cables are there. One is unshielded twisted pair cables, second one is shielded twisted pair cables. So most of the scenario structure, when you go for this FM transmission kind of structure, so we are going to use in this shielded twisted pair cable structure values only, because it shows impact on the reduction of my noise values only. And second one is coaxial cable. So what is coaxial cable? Coaxial cable is very commonly used in transmission media. For example, when you go for this in the general communication, TV communication purpose, also we are using this a coaxial cable values only, because this wire is usually a coaxial cable. So what is coaxial cable? When you see in the previously twisted pair cable, we having as one copper wire is there. On top of that, we having as one kind of a plastic sheet value is there. This is my copper wire, and which is insulated wire, and this is my a kind of plastic metal, dielectric metal values only. But while I'm using this coaxial cable structure, in the coaxial cable structure, I am going to give 2 to 3 shieldings are there, because this is my center connector, which is my copper material. On top of this one, I'm using as one kind of insulator, and one kind of shield purpose, and one kind of jacket purpose. So these are the shows impact on my performance level. Why? In the sense, here I can able to transmit the power supply of 5 volts power supply, but in this coaxial cable, I can go for this up to 230 volts power supply. So this much of amount of power supply is producing, and this is the frequency of this VHF range values and UHF range, very high frequency value and ultra high frequency value. That much amount of frequency I'm using that one, it may having as a emission values. It shows impact on this wire damage values. So if I'm using this insulated material and shielded material, so it reduces emission value, my information is transmitted smoothly manner only. So that is the reason. The inner connector of the coaxial cable is made of copper, and this outer connector is made with copper mesh. So this is the copper mesh value and some kind of insulated material values only. So we'll see this one. This is inner connector should be the between the countries a non-connective copper separate values only, because when you see this one, the information is transmitted from one end to another end. So one end to another end. So here I'm producing the frequency value. That frequency is transmitted through this cable values only, right? So this amount of frequencies, n number of cycles are there, because frequency rate is very high. What is the frequency? F is equal to 1 by T value, and this amount of frequency is there, producing the frequency is there, and time factor is there. So n number of cycles are producing between this coaxial cable values only. So here every amount of emission should be possible. Radiation emission is very high. That shows impact and damaging of my material, my cable values only. To overcome that kind of issues, to overcome this, damaged kind of cable values only. If the cable is damaged, the signal is getting leakage. If the signals are leakage, it shows impact on my output performance. The efficiency goes to be very low. To overcome all this scenario, we are going to using this kind of structure. So in the coaxial cable, this is the information is transferred from one end to another with help of this 2 to 3 shieldings. We are using that one. And how many types of coaxial cables are there? One is baseband, another one is broadband. So generally in the TV communications or broadband communication level, in the DTH communications level, we are using this kind of transmission value, which is information is transmitted from one end to another end values only. And next one is a fiber optic cable. So what is a fiber optic cable? As we discussed earlier, so when discussing about this twisted pair cables, or when discussing about this coaxial cable, here the information is transmitted in the form of this electromagnetic wave values in the form of this is sinusoidal signal formation. But in the fiber optic cable, that uses electrical signal for communication, and this fiber optic cable, which means it holds the optical fiber and which is coated with the plastic, and that is used in the form of this. Here the information is transmitted in the form of this a light rays values only. We calling as a pulse of light rays values only. When you see in the coaxial cable, we having as a copper wire is there, insulated material is there, and top of this one we having as a shielded twisted pair cable is a kind of copper mesh is there. But while go for this a fiber optic cable, we having as core material is there and cladding is there, which means the coating material is there. At the same time, when taken about this one, this structure, the strength of member values is there. So here when the information is transmitted in the form of this light rays, which is very much difference between this information is transmitted in the form of this sinusoidal wave values only. Here information transmitted in the form of this as sinusoidal signal values only, but here information is transmitted in the form of this a light rays values only. So the amount of speed is very high compared to the coaxial cable. The information is transmitted in the form of this light rays. The amount of speed structure is very high. So because of that reason, we are using this different kinds of structures. We are using that, which calling as a core and cladding structure value is there. And this is coating will protect the optical fiber from heat values, cold values, electromagnetic interference values, and other type of wiring values only. When you see nowadays we are able to use this fiber optic cables to drag the to align the information from broadband communications in the high-end communications values only. In the even the satellite communication also we are in this fiber optic cable, because it can able to taken care about this heavy amount of heat conditions, heavy amount of cold situation condition. The information is transmitted from one end to another end values only. That is a major advantage of this fiber optic cable. And so in this session, we are focusing about this transmission media. In the transmission media, we having as a two things are there. One is wired communication, which we calling as a guided media, and second one is we calling as a wireless communication, we calling as a unguided media. So in this session, we focusing about this a guided media, which means what kind of cables we have used that one and how they works that one. We are discussing in this session. In the upcoming session, we are going discussing about this unguided transmission media. So in the unguided transmission media, apparently we calling as a wireless communication media, how the information is transmitted through a wireless mode. We discuss in the next session. Thank you.